Okay, chapter 9, number 55. We have some atom and it decays and spits out a neutrino and an electron at right angles. Maybe this isn't quite how it looks. Maybe the right angles, the neutrino goes this way and the electron goes this way. We don't really know. All we know is that the neutrino and electron are at right angles from each other, and the nucleus goes in another direction. Okay, so the neutrino has momentum of 6.2 times 10 to the negative 23. Now I said I made it in the positive y direction. That's just how I drew it. Doesn't matter how you draw it. Okay, so the momentum of the neutrino, that's what the n is for. Momentum of the electron, E, is 9.6 times 10 to the negative 23 kilogram meters per second. So what's the momentum of the nucleus and in what direction? So the formula to use is a conservation of momentum. So let's get this going. There now. All right. It's 2 plus 3. So it's the total momentum before will equal the total momentum afterwards. Okay. The total momentum before was 0. It's not moving, so at least not with relation to in relation to the other. Okay. So P1. Let's call P1 the nucleus. Sorry, the neutrino. And P2 we'll call electron. And P3 we'll call the nucleus. Now this is true that their vectors are conserved. Okay. So taking that into account, we need to look at the x and y directions of each. So in the x direction, 0 equals, well, the neutrino is not moving at all in the x direction. It's moving in the y direction. So that's 0. The electron has momentum of 9.6 times 10 to the negative 23. And the nucleus, we don't know. So with that, we get that negative 9 point to the 23 to the negative 3 gram meter per second is the momentum for the nucleus in the x direction to the y. Well, y direction is 6.2 percent. I should really keep the units in there. For the electron is not moving in the y direction, so that's 0. By the way, this should be x, this, and the y direction. Okay. So it's a negative 6.2 times 10 to the negative 20 meters per second. That is the momentum of the nucleus only in the y direction. So we've got motion here in the negative x direction and motion here in the negative y direction. The resultant vector is here. So we need to find that. We can do that using Pythagorean theorem, but we also need the angle. We'll get to that later. Pythagorean theorem says that the square root of the nucleus momentum squared in the x direction plus the nucleus is in the y direction squared will equal there. Okay. So if we plug the numbers in, the momentum comes out to be 1.1428 times 10 to the 23 negative 22 kilogram meters per second. So the sig figs be 1.1 times 10 to the negative 22 kilogram meters per second. Now looking at this here, we've got p in the x direction, p in the y direction. We want to find the angle tan theta equals opposite over adjacent. We plug those numbers in. We find out that theta is inverse tangent of in the y direction over p nucleus the x direction. If we find that, theta turns out to be 33 degrees, or 2.857 degrees, which is 3 degrees. Now, let's keep in mind though that that's just this. When we compare it to the neutrino, we want to add another 90 degrees. So 90 plus the 30. 90 plus the 33. So 90 plus the 33 will be 123 for the neutrino. Okay. Now on the other side, this is 180 minus 33, right? 180 minus 3. So that is 180 minus 33 degrees. 147 degrees from the electron. You're done.